A warm greetings to the honorable examinees. I am Jeevaneswaran Kuppusamy, who would like to present on my final year project, which entitled as Protein Extraction for Ruminant Feed from Chicken Waste by using subcritical water technology. These are the presentation outline of my research. So now, let's jump into the main presentation. Chicken are the most common type of poultry in the world and has a higher demand for their meat. Based on the Department of Veterinary Service Malaysia, about 800 millions of chicken have been consumed in just a single day, which have ranked Malaysia at the 7th place in the Asia. This higher rate of chicken consumption have increased the waste generation from it, which consists higher percentage of chicken feathers. This byproduct will usually be dumped in landfill, which leads to harmful gas emission to the environment that can cause major problem to the environment and public health. But do we realize that this chicken waste contains about 83 to 90% of protein, which actually can be converted into valuable products? Thus, this explanation leads to few problem statements that need to be considered. The first problem arises is around 83 to 90% of protein which found in this chicken waste are end up in the landfill as a waste and releases harmful gases such as methane and ammonia to the surroundings. The second problem is high cost in producing and importing nutrient-rich product for ruminant that could lead to insufficient nutrient supplement for the ruminant. While the third problem is most of the conventional method for protein extraction from chicken waste are expensive, time-consuming and non-eco-friendly. Therefore, three objectives have been set up in this project. The first objective is to extract the protein available in chicken feathers by using subcritical water treatment. Next is to study the effect of solid to liquid ratio and retention time parameters on the extracted product of subcritical water treatment. While the last objective is to scale up the optimal parameter to mass scale by using multi-purpose recycle machine for ruminant feed. Thus, the scope of my research is to study the effects of parameters on the production yield and scaling up the optimal parameters to mass scale by using multi-purpose recycle machine. Hence, subcritical water treatment have been selected in this research for the protein extraction. This treatment is quite similar with the hydrolysis treatment where it uses solvent to break down the strong bond between the organic compounds and extract the protein. In this treatment, water will be used as the solvent which has a dielectric constant about 79.9 at the ambient temperature. This treatment operates at the temperature between 100 to 374 degrees C, which is above the boiling point with the help of operating pressure between 1 to 22 megapascal. At this point, the solvent is able to reduce the dielectric constant to a range about 27 to 32.5, which enable to break the strong bond between the protein and solvate the low intermediate polarity compounds. As for the research methodology, a total of 3 parts have been divided, where the first part is known as the preparation of chicken feathers as the raw materials. Firstly, about 15 kg of chicken feathers were collected from the nearby wet market at Datuk Kramat. Since a mixture of chicken waste have been obtained, a graph sampling of chicken feathers from other type of chicken waste were carried out. Then, these feathers were rinsed with hot water and being filtered using a strainer. Later, oven drying of feathers have been carried out at a temperature of 70 degrees Celsius for 24 hours. Finally, the dry sample were cut into smaller pieces and stored in an airtight plastic bag. These feathers were then used as a feed in the SCW reactor for the extraction process. Once done with the preparation of raw material, extraction of protein from chicken feathers have been carried out. A 30 gram of prepared chicken feathers were weighed and fed into the SCW reactor along with 600 ml of water based on the solid to liquid ratio of 1 to 20. Then the experiment was begun in SCW by setting the temperature at 170 degrees C with a rotation time of 30 minutes on the control panel. At the end of the process, the solid product was filtered while the liquid products were collected. Both of these products were then stored separately in a different vial. Later, the obtained solid product was dried at a temperature of 120 degrees C for 1 hour in order to remove the moisture completely before it is being proceeded for mass reduction and moisture content analysis, while the obtained liquid product undergoes the pH analysis. Further analysis of CNS content, protein composition and microbiology growth were proceed based on the pH and percentage of the mass reduction of the product. Finally, step 1 to 5 were repeated for the next set for 45 minutes and 60 minutes. An additional run of solid to liquid ratio at 1 to 10 for 30 minutes also have been carried out. And the last part is scaling up the optimal parameters to mass scale. This part begins with the identification of previous run mass of chicken feathers in MRM, which was 338 kg. By using the ratio of 1 kg of sample to 1 liter of water, the solid to liquid ratio required for MRM has been determined. Then the optimal parameters obtained from the SCW was scaled up to MRM. Next, in order to convert the obtained liquid product into a dry powder for ruminant feed, a freeze dryer was proposed to carry out the drying process. And finally, the method of ration formulation of protein feed composition for ruminant feed by using Pearson square method was also been proposed. Now, let's move on to the result part of this research. As can be seen in the figures, these are the products obtained at a solid to liquid ratio of 1 to 20 and 1 to 10 for respective retention time from 30 minutes to 60 minutes from left to right at an optimum temperature of 170 degrees C respectively. As can be seen for ratio of 140 and 120, the color of both solid and liquid products were turning into a darker color as the charring process begin to occur as the rotation time increases across the solid to liquid ratio. This is because more feathers were degraded, causing more nutrients to break down and dissolve into the solvent. From this, it can be said that darker color shows a higher concentration of liquid product, thus higher the mass reduction. While for the solid to liquid ratio of 1 to 10, both solid and liquid products were less concentrated than the ratio of 1 to 40 and 1 to 20. This is due to the lower moisture content in feathers and concentrated solvent ratio, which makes the breakdown of nutrients tough that result in lower protein extraction. Therefore, the ratio of 1 to 40 and 1 to 20 will proceed for further comparisons. As can be seen in the mass reduction against rotation time graph, there is an increase in the mass reduction of solid products across the rotation time for both solid to liquid ratio, and increasing in the rotation time causing the feathers to be exposed in a heated surrounding for a longer period of time. Thus, the longer the rotation time, the higher the rate of degradation. However, the mass reduction ratio of 1 to 40 is higher compared to 1 to 20 because the higher the ratio, the lesser the solvent to degrade the solute. While for the pH against rotation time graph, it can be seen that the pH of all the liquid product obtained were below 6.0, which proves that the presence of the protein. The lowest pH was obtained at a ratio of 1 to 20 with rotation time of 45 minutes, which was 5.19. Thus, a higher concentration of amino acid was extracted at these parameters, and this liquid product was proceeded for further analysis. Based on the analysis result, a concentrated amount of protein were extracted in solid to liquid ratio of 1 to 20. About 8.53 gram of TOC, 2.8 gram of N, and 0.029 gram of S were found in the liquid product at ratio 1 to 20, which is higher compared to ratio of 1 to 40. The presence of TOC, N, and S had proved that the SCW pretreatment have successfully done its extraction process. The presence of TOC and N had proven that the SCW pretreatment had successfully extracted the organic and amino acid compound respectively from the chicken feathers, as amino acid is composed of nitrogen atoms in it, while the S content proved that the SS bond in the chicken feathers had successfully break down and turned into a soluble product. Thus, this shows that all the nutrients have been broken down into the soluble nutrients into the solvent from the chicken feathers. As for the composition of amino acid in the liquid product, it also can be seen that the percentage of amino acid in solid to liquid ratio of 1 to 20 is higher compared to the ratio of 1 to 40. The major composition, which includes threonine, arginine, lysine, and lysine, are being extracted with other minor composition as well. Since these major composition of amino acid are required for the ruminant healthy growth, high milk production, and protein source for ruminant cell buildup respectively, hence this liquid product is potential to be used as a supplement for the ruminant feed. These have proven again that the SCW had successfully extracted the protein required for the ruminant feed. Next, in order to prove that the liquid product is suitable to be used as protein supplement in ruminant feeds, the analysis of presence of microbes in the liquid product have been carried out. Based on the analysis result, it can be seen that the E. coli value is in the range of the acceptable level, which is below 126 colonial forming unit over ml. While for the other species such as Salmonella, Pseudomonas aeruginosa are being not detected. This has proved that there are no harmful microbes were present in the liquid product. Therefore, it is safe to be used as the ruminant feed. Once done with the analysis and have identified the optimum parameters, the scaling up of SCW to MRM have been carried out. About 338 kg of chicken feathers were fed into the MRM. According to the optimum parameters obtained, a setup of solid to liquid ratio of 3:1 at 1 megapascal for 45 minutes have been proposed in order to obtain a higher amount of liquid product with a concentrated amino acid. About 100 liters of liquid product and 2 to 9.84 kg of solid product are expected to be obtained. Since a liquid product is more preferable for ruminant feed, thus a freeze-dryer method also have been proposed in order to convert the liquid product into a dry powder and formulated them for the ruminant feed. Finally, a Pearson square method has been proposed for the formulation of protein feed composition for the ruminant feed. A 90% of dry method basis was used in this formulation. The steps that are involved in this calculation are shown as below. At the end of this calculation, the percentage of liquid ratio required for the ruminant feed as well as the weight of the liquid feed could be determined. Table below shows the formulation of feed for dairy cow that can be achieved by using this method at the optimum parameters obtained. Therefore, as a conclusion, a concentrated amino acid has been extracted from the chicken feathers by using SCW pretreatment method. Besides that, based on the analysis that have been carried out, it can be said that the SCW pretreated products are safe to be used as the protein supplement for the ruminant feed. Other than that, an optimum parameters of solid to liquid ratio of 1 to 20 with rotation time of 45 minutes at 170 degrees C were determined. Then, these optimum parameters have been scaled up to MRM and at proposed Pearson square method for the ruminant feed formulation. Hence, as a future scope, combination of chicken waste can be used at these optimum parameters in order to extract a concentrated liquid products. That's all from me. Thank you.